When we think in multiple variables at once, the problem becomes quickly a little bit more complicated than it does in 2 dimensions. We're fairly familiar with various functions in 2 dimensions, linear, exponential, quadratic, cubic, all that good stuff, but we're a little less intuitive about graphs in multiple variables. So let's look back at the cost to move model. And so what we're going to do here is we're going to kind of construct graphs for multiple reduction functions. Remember, a reduction function is just whenever we take a multivariable function, we reduce the number of variables by holding one or more of those variables fixed. In particular, we're going to want to take something like a 2-variable function. Remember, that means we say 2-variable function whenever the number of input variables is exactly 1. So what we want to look at here is we actually want to look at the function c of d and m, where we are going to, in the first question, hold the number of days fixed at 1. So we're going to assume that your cost to move with a moving truck is $19.99 per day and 47 cents per mile, like something like a U-Haul truck. And so we are going to hold that fixed and take a look at the corresponding graph. Well, we know that this function reduces down to c equals 1999 times 1, which is just 1999, plus 0.47 times m, which is 47 cents per mile, times the number of miles. And I'll just go ahead and tack on the 1999 here at the end. And already we see that this is a linear function with a slope of 0.47. So we'll go over to Excel. And in Excel, this is an incredibly nice feature of Excel. We can actually do a couple of things here. So what we'll do is we'll keep track of cost and the number of miles. Okay, so first of all, excuse me, not cost. We'll keep track of the days and miles. Okay, so we'll just say we're going to hold on column C, and this, the way I have this set up is we'll look at 1 day, and then we'll look at the number of miles. So we'll just say, I don't know, we'll go 0 miles, 10 miles, 20 miles, 30 miles, 40 miles, and so on. Well, I'm getting kind of tired of adding 10 miles manually. So what I'm going to do is I'm going to come over here to my second cell after the 0 mile marker, and I'll just say equals the previous number of miles plus 10, so I can go in 10 mile increments, and then I'll just copy this cell, and I will go ahead and paste it, I don't know, maybe over to this column here. So it'll give me a nice variety of values, so I don't have to type those in manually. Okay, well, I know that the way cost is calculated is equal to the number of 1999 times the number of days, which is listed over here. Right now we're holding that fixed at 1. And what I want to do is I want to lock this column, and you'll see why in a second. If I just press enter now, and I copy this and move it over here, what it's actually doing is, wow, that's very expensive to drive 10 miles for 1 day. It's actually taking the cell to the left of it and multiplying it by 1999. What I want to do is I want to always be referencing the number of days in this cell. So what I can do is a couple of things. I can call this column, I can go ahead and just refer to that. So what I'm doing is I've highlighted the entire column, and I'm going to call this days and press enter. So now that'll make things a little bit easier. And you can see if I highlight it again, it's still called days. And I'm going to call this row right here, I'm going to call that miles. So I come up to the top here, press miles, enter. And so now what I can do is I can just type in equals 1999 times days. And you can see that what it's doing is it looks like it's referencing that entire column. Well, what it's actually doing is referencing the value that's in that column, but in the same row. So equals 1999 times days plus 0.47 times miles. And it knows to grab the number of miles. You can see the word is in red and the row is in red, so I'll press enter. And right now, because I'm driving 0 miles and I'm renting the truck for 1 day, I'm going to pay $19.99. And now I can go ahead and drag this. So I'm going to grab the corner. You can copy and paste, but if you get the little crosshair there, and copy, drag that all the way across to the very end, and you'll see that those values populate. So $24.69 should be the total cost if I took the truck for 1 day for 10 miles. Well, that's 47 cents a mile. So at 10 miles, that'll be $4.70, and $4.70 plus $19.99 is $24.69. So this looks pretty good. Okay, well, so now if I wanted to graph this, what I could do is I could say insert, and I'm going to insert a chart. And for now, I'm going to go ahead and insert a 2D line, and I want it to, let's see, I want to pick the, actually I want to go to scatter plot because that'll allow me to create a curved graph in the event that that would be necessary. And I'm going to select my data, and what I want is to add entries, and I'm going to basically name my series. That's going to name my graph for me. So this is going to be total cost. And now you can see that populates, and my x values are actually listed in this row. Those are my x values. And now my corresponding y values are listed right below that. So I want to plot days versus the number of miles. And you can see that I get the total cost, and I get based on the number of miles. So this is assuming that we fix the number of days to 1. Now I can also come in here, and I'm going to OK this. And we'll say OK again. And now I can add some features, and I want to add some axis titles. So this one I want to call the cost, and this I want to call the number of miles. And the total cost, actually I should say, is for m equals 1. In other words, this is only the total cost function for moving if m equals 1. The number, d equals 1, the number of days equals 1 day. Okay, well, I could do the same thing for another series. I could say, you know what? I actually want to take a look at the total cost for moving for 2 days. Okay, well, I could kind of repeat that same process, and the way in which I would do that is very similar, but instead of actually changing this to 2, I want to create a new row. I want to be able to maybe even draw comparisons here. Well, here's another thing I can do. I can highlight this entire row of output values. So inside of this, you can kind of see that this is a contingency table, and that we have days and miles over here, very similar to a contingency table in probability, except the outputs are the total costs. And this seems to make sense. Okay, so if I rent for 2 days and drive 0 miles, then my total cost will be $39.98. And then this should increase by the $4.70 to drive the 10 miles. Okay, well, now I want to go ahead and grab the corresponding data. So what I can do is click on the graph, and then what I want to do is I want to drag that bar down. So now I want to look at the total cost, and you can see that that's shifted up. That's the exact same graph, just shifted up from a horizontal or vertical intercept of $19.99 to a vertical intercept of $39.98. And we can see that the function has not changed in its slope. It has just changed its position on the axis, the y-axis. Okay, so there is my total cost function, d equals 2. And gosh, I could keep doing this for another day. I could say, what if days is 3? Okay, well, I could similarly grab that row because I've nicely created this column. I've called it days, and this row 3, I've called it miles. So I can just reference 19.99 times days plus 47 cents times miles. And I could do the same thing again, click on the graph. And what am I going to observe? I should observe that the rate of change of the graph hasn't changed, but the vertical intercept has. So when we come back here and we were to write this reduction function for days equals 2, the reduction function would look identical in almost every way, shape, and form except where it hits the vertical axis, where the function hits the vertical axis. So in this case, for d equals 2, I'm looking at the reduction function c of 2 comma m, which is going to be 19.99 times 2 plus 47 cents times m, which reduces to, well, really 47m plus 39.98. Now this is the fixed cost, renting the truck for 2 days, assuming I drive m miles, which could, potentially vary. Maybe we want to study if, as I increase the number of miles, what's going to happen to my total cost. Now back here, I was only renting for 1 day, so my fixed overhead was $19.99. Well, this is great, but I want to look at it at the same time for a bunch of values. So this means, what if days is between 0 and 10? So I'm still fixing that value, but I want to look at it for multiple days, 0 to 10 days. So what I'm going to do is I'm going to come over here, and I am going to actually make an adjustment here. So first of all, I'm going to set, well, I don't want to have to count down to 10, so I'm going to say equals the day 1 plus 1 day. And now I can just grab this cell and copy it down until I get to 10 days. There we go. And then I can grab this row and copy it down, and then it should populate the total cost under the assumption that I rent for 10 days. Well, it's going to be very expensive to rent that truck for 10 days without driving it at all. Okay, well, so now I can look at any one of these, and I notice again that the only difference between these graphs is the vertical intercept. And you know, they look very identical. Now, what's happening here is the scaling is changing, so it looks kind of funky, but nonetheless, it is exactly the same slope, and we could prove that by plugging in the corresponding number of days. Well, what if I wanted to look at all of these simultaneously? Well, one thing I could do is grab this corner and highlight all of the data cells, and right away you notice that from bottom to top, I have the days equals 1, days equals 2, days equals 3, days equals 4 under the variable, the number of miles, and I'm looking at the total cost. So as we mentioned, the lines are parallel. They have exactly the same slope. The only difference is the vertical intercept. Well, I like this graph, but it's kind of clunky. So I'd like to see maybe a third dimension. Maybe I want to look at cost versus miles, but then I want to have another axis that keeps track of my number of days that I travel for. Well, that's easy to do. I can right-click on my graph and say change chart type. And from the chart types, I want to select line chart. And what I want to do is come over here and select 3D lines. Okay, so what that will do is now when I press OK, now I notice that I have cost versus miles and sort of this depth. If you can see this in 3D, the depth actually keeps track of the number of days. And again, now I kind of more clearly see that, you know, there's some distance between these two lines this way, but the red line here is actually above the blue line below it. And so now I'm actually looking at 0 days between 0 and 10. And I've got a perfectly nice graph that illustrates that. I could also come over here and tell it, you know, where it's pulling these values from. So I'm going to say, let's see, select data, and I'm going to edit the series, and I want the series name to be right there. Oops, that's not what I wanted. Cancel that. We'll cancel out of there as well. So I'm going to grab, nope, that's not going to work either. I think it's actually going to be easier for us to just go ahead and remove that graph entirely and insert a new one. Sometimes Excel can be a little nitpicky. And so from the insert chart type, I will select 3D line, and now I can select my data. And I'm just going to try this. Let's see. So my series name is going to be cost, and my series values are going to be these values here. All right, I think I've got it here. So we are going to actually insert just the first row. Depends on what version of Microsoft you're using, but it can be kind of picky. So I'll insert a 3D line just for the first row. So right now you notice that this is just cost versus the number of miles, or right now it's the wrong labeling here. So we're going to make some updates to this. We're going to now select the data, and we actually want to change the horizontal axis label to be from 0 to 90, and we'll click OK. And so that changes this to the number of miles. And I want to name the series. That just means name the value of the variable. So that's for 1 days. So I'll click inside the series name box and select 1 days and click OK and click OK again. Okay, so there I have it. I can insert axes titles so I don't forget what I'm looking at. So this is my cost.